everyone. As you probably know, today is Pi Day. So basically, I decided to dedicate a videogram audio-visual experience to this very special number that is roughly equal to 3.141592653589799323846264338327950228. So there are a number of situations where pi just seems to appear out of nowhere when you least expect it to, and this is what I intend to show you. The first one was covered on 3 blue 1 brown, so if you want a precise explanation of the math behind this one, I recommend watching there. Anyway, in this simulation I coded up in C++ using SDL library, perhaps in the most scuffed way possible. I simulate the movement of 2 cubes moving onto a frictionless plane and colliding between each other. Let's set the mass of the incoming cube to the same mass as the other cube and give it an initial velocity. As expected, due to the conservation of mechanical energy in this elastic collision, the cube transfers all of its kinetic energy to the second one and reciprocally for the other one on its way back. For a total of, counting the wall, 3 collisions. As we increase the weight of the first cube to 100 times the mass of the second one, it loses less energy on the first collision, thus taking more collisions before going the other way eventually. Now 100 squared times the weight of the second cube. (100 cube times) (100 to the power of 4). The digits of pi indeed seem to magically appear from this otherwise simple physics simulation. The simplest explanation I can give is that the conservation of energy gives half m1v1 squared plus half m2v2 squared is constant throughout. That is basically the equation for an ellipse, and if you change the axis to square root of m1 times x and square root of m2 times y, you get a circle. Now the conservation of momentum gives you m1v1 equals m2v2, so during the collision, the points between both states stay along the line of coefficient square root of m1 over m2, giving us the next spot on the energy circle, and when the second mass hits the border it is equivalent to flipping its velocity. Then repeat the process. The circle is then cut into segment of equal length, forming a theta angle with the circle's center. Finally, you can determine with the inscribed circle theorem that theta equals arctan of square root of m1 over m2, which comes out to pi. So as m2 gets larger, arctan of x becomes closer and closer to x, and thus theta is approximately 1 over the square root of m2. So if the circumference is 2 pi, you divide both and everything check out. If none of it made any sense, I literally didn't ask. Anyway, another little experiment I like is the Buffon's needles problem. Named after French mathematician Georges Louis Leclerc de Buffon. Again, this topic is widely covered online, and I would personally recommend Coding Train episode 169. So this guy just made a mess by throwing a whole bunch of small needles on the planks of his floor and counting the amount that crosses a border between 2 planks. This guy should probably spend some time touching grass, but I guess you're also here watching this. Anyway, using 2 nested integrals to calculate the probability of not crossing a line and integrating the angle and the distance with the closest border, you get a final result that pi is roughly equal to 2 times the quotient of the number of needles over the number of them that cross a line. This kind of neat little stuff is called a Monte Carlo simulation, and it consists in studying probability on a random event using a computer program. So that's pretty cool. And even though these methods are terribly inefficient to compute the digits of pi, I am always amazed at how pi tends to pop out of nowhere. Some much more efficient ways to compute the digits of pi include convergent series that get increasingly close to pi the more terms you compute. As a sort of benchmark, I will run parallels simulations using C++ to see which of these method provides the fastest result. As we can clearly see, out-colliding cubes and flying needles cannot keep up with the series approach, but let's admit it, they are a whole lot more fun. That's it for today guys, hopefully you enjoyed this video and I'll catch you in the next one.